All right, let's give this problem another shot. I'll change it up a little bit. Let's just say it is 35% HCl and a density of 1.15 grams per milliliter. And let's just go from there. So, mole fraction. Another way to do this, and it really doesn't matter, but it might be easier to do this. If you have a liter of it, all right, so 1 liter, then the mass of it would be 1,150. And that comes from just taking 1,000 milliliters and timing it by that. Okay, we chose 1,000 before. Either one is just fine to do. All right, now if I multiply this by 0.35, I will determine the grams of HCl. Okay, so I end up getting 402.5 grams of HCl. All right, the rest would be the grams of H2O. So I'm going to take 1150 and subtract 402.5, and I end up with 747.5 grams of that. For mole fraction, I need moles of both. So this is 36.5 again, and this is 18 again. All right, so I went ahead and did all the math, except for dividing, I guess, to get the actual answer in the end. So what I did here, I took 402.5 grams, and I divided by the molar mass of HCl, and I got 11.05 moles of HCl. Over here I took 747.5 and divided by 18 and got these moles of H2O. Then I took the 1102 on top, I put the total on the bottom, 1 second, and then I divided, and I end up with 0.2096, we'll call that 0.21 is my mole ratio of HCl. Okay. All right, the molality, I need the moles of HCl per kilogram of H2O. So I have both of those. The moles of HCl was 11.02, and I can divide that by the kilograms of H2O, which I found to be right here. But it's a decimal, 0.7475. Type that in, and I end up getting 14.74 molal. That's hideous, but whatever. It's a little behind my hand for some reason. All right, now the molarity. Is the moles of HCl per liter of solution. Okay, now, in the example I did in class, we used the density here. In this example, I used the density here to already find that a liter had this much mass, so have these many moles. So this way is actually a little bit easier, probably in the long run. So I have my moles is 11.02. All right, and I need it over 1 liter of a solution, which I already had because I put it right here. So it's just a 1. So I end up with 11.02 molar solution. All right. I'm not going to worry about D too much. If you need to review chapter 4, it's gas producing reactions with acids. So when carbonate reacts with an acid, it's going to make H2O plus CO2. All right, in E, let's say you have 75 grams of calcium carbonate and we'll say 2 liters of the above solution. All right, and we're gonna calculate this. So we do the same thing we did before. We convert both of these to moles. The above solution was HCl, to see which one is our limiting reactant. So I take my 75 grams and I divide it by 100 grams. Now that seems like, why would I do that? But that is what a calcium plus a carbon plus 3 oxygens, when you add up their molar mass, it ends up being 100. So we have 0.75 here for the moles. And then I have 2 liters, all right, times, the molarity was 11.02 moles. So you get 22.04. So time out. All right. I did this pretty dumb because I wanted this to be my limiting reactant, but whatever, it wasn't. So we'll just live with that. It makes this the limiting reactant because this number is definitely 2 times bigger than that number. All right, so then we take our limiting reactant, erase this, which was 0.75 moles. We converted it to moles of CO2, and that was CaCO3 here, CaCO3 on the bottom, CO2 on the top, and those were moles and moles. From the balanced equation, there was ones in front of both of these. So it's just 0.75, which we then pivnert. All right, so V equals nRT over P. So 0.75 times 0.0821 times my temperature was 300, divided by my pressure, which was 1, and you'll get a number. Okay. You can calculate that. Let me get the information for this, and then we'll work through that real fast. All right, so hopefully you can follow my logic here. I've already written everything out, and you'll have this equation on the smartboard. So you won't have to have that memorized, but you got to know what to do. So the first thing you're going to do is take your normal boiling point and make sure you add what your answer is to get what the real answer is. So you may remember, we talked about this before, but the boiling point change is measured by taking kV and multiplying it by the molality. kV is pretty easy to find because it is given to you in the problem. It's right here. Okay, so that's where the 1.22 came from. This is bugging me. Hold on. It's going to continue to bug me. There we go. All right, so really the only hard part of this question is finding the molality. And this is hideous, but just follow my logic here. The molality is equal to the moles of CaCl2 divided by the kilograms of your ethanol. So the first step I did is I took the 150 grams and I divided it by the molar mass of CaCl2. All right, that's just the parts added together, and I end up with 1.36 moles of CaCl2. Now, to find the kilograms of your solvent, I came over here, I took my volume, and I multiply it by my density. These were both given to you in the problem. So 750 milliliters times 0.789, I end up getting 591 grams of solution. The problem told you you had 150 grams of solute, so that's where that number comes from. To find just the solvent, you subtract those two and you get 441.75 grams. Now, we're ready to roll. We have the moles already. Just remember, molality is moles per kilogram. I just converted grams to kilograms and put it underneath. Now, I divide those answers, and I ended up getting 3.08. And that is not the answer to the question on the test. All right? And it's not what you add either. That is the molality that comes up here. So now you take your boiling constant, you multiply it by the molality of the solution, and you get 3.76. And remember, this is not the answer. Tons of you will put that as the answer tomorrow. That's what you add to the normal boiling point. 78.4 is what it normally boils at. When we did this, we found the change in temperature. So I add. The reason I add is because boiling point is elevated. If this question tomorrow says freezing, you have to subtract. It's the exact same math, except for you subtract at the end. So once you add this, you end up with your new temperature being 82.15, and that actually is your answer. And I am done. Thank you, third hour, for being silent.